Well, welcome back to Lunch with Larry. Today we're going to talk about verification and validation in the heavy equipment and energy space. We're a trusted Siemens partner for resale of Polarian, so we'll talk a little bit about how Polarian can be used for doing test management. So I look forward to the discussion today, and thanks for coming. So just some contact information for me. If you want to send the registration link or get on my YouTube channel and subscribe, this is all the information for getting there, or schedule a meeting with me. So I just want to make sure you have my contact information. So when we talk about design ideation capabilities, we've talked about this in the introduction. Essentially, we have these 5 different areas, but the core of all of this is requirements management. So what we're really trying to do with these different perspectives is get a complete understanding of our device function. And how is it that we show evidence that the requirements that define what is good product, how do we show evidence that that testing has been done in a way that's structured against how we believe the device should function or how the design should function. So again, today is verification and validation. That's our number 2 session. Next week, we'll be talking about risk management, then standards management. How do we map in external standards and our company SOPs into a view of what we want the design to do? And then finally, we'll talk some about systems modeling. How do we do functional mapping across multiple components of the design? So that's the order of events here, and today again is V&V. So when we start out with V&V, of course, we're going to start with the core data model. And the core data model in this case is going to be this deconstruction from user needs refined by system requirements, design requirements, physical requirements, and then finally process controls. When we have all of these controls built into the system, what we're going to have is a complete set of everything that we can control related to the design, including any requirements for users, any requirements for labeling, the instructions for the use of the design. All of that is baked into the requirements set. So if we have all these design requirements in place, this gives us the full deconstruction, so that all the way down to production, to show that the design is going to function the way that we intend it to. So we also have refinement relationships in the requirements that allow us to have parent-child relationships with each level of the requirements. So what this really means is, when from a reporting standpoint, it's always going to be essentially 5 columns deep if we want to just show the controls. Our test cases then are going to be written against each level of the requirement, and the test cases that are written against the user needs are the validation. The test cases written against the lower level requirements are going to be the verification. And you can imagine that the validation will be done by the process companies that are engaging with an equipment supplier in order to get a certain process built into their company. So essentially, if you wanted to control a wellhead, or you want to do refinement of hydrocarbons, or you want to produce a chemical, the user needs define what it is the process company needs out of the design. And so once the equipment supplier produces the design, then what they're going to be checking against are whether those user needs are delivered or not. So that's really the validation step. Or as we're writing the requirements below, what we're trying to understand is whether the design complies with our definition of how those user needs will be met. The example that I've always heard is, if we're building a building and the user needs the room to be warm, we're going to have system, design, physical requirements, and process controls to produce the building. And so we're going to have a certain CFM of the air delivery system. The air output is going to be of a certain temperature. We're going to have reclaim of the air that happens in a pressure regime. So what we're trying to do there is understand what we need to do in the building to assure that the user's warm. Well, so we go build it, and the verification says, okay, yeah, it's the temperature's right, the airflow is right, but at some point in time, we need to bring the user back into the building and say, are they warm? And that's really that validation stage. So usually validation's performed by the end users, and the verification is done by the engineering staff that's developing the design. And so that's really how that deconstruction happens. So we have a couple different test case types, and we separate them intentionally so that we can understand the difference between end use and what the engineering staff is delivering. So how does test management work? Essentially, we have these test cases that are related and linked to the requirements, and we have a test protocol that's going to build out those test cases for a particular type of problem. So, for example, if we wanted to test a subassembly or a particular part in the design, we might have a test protocol that's related only to the testing that's related to that subassembly. So those protocols can be scoped any way that you want them to. And oftentimes when we do a test run, we're either going to test the full set of test cases that are included in that protocol, or we're going to do a smoke test of a couple of them just to be sure that we think we're going to end up in the place that we expect to be. So the test management system allows us to scope the test cases into protocols and then execute on either the entire set or some subset of those test cases. Very flexible system to allow us a process to tighter into the design and understand, kind of what is the current status of the design versus what is the finished status. Some of the related topics with test management that come up quite a bit. Polarion is a test management system, but it doesn't keep track of calibration of the different test articles that are out there or the test equipment that's out there. So calibration is one thing that needs to be discussed, and we have to have an understanding of how the calibration is tracked as part of the test evidence and the test history. Also, test methods. It's not uncommon that you would create a test protocol and then validate that test protocol to be sure that the testing that's being done, has an appropriate gauge R&R so that we know if the test is repeatable and reproducible. So test methods are often used as a validation to say, okay, we have a certain measurement we're going to do. Here's how the measurement should be done so that we get a valid result. And of course, test automation, it's not uncommon, especially in software, for us to have thousands upon thousands of test cases. If that's the case, oftentimes what we want to do is execute automatically a test over and over. Cybersecurity is one really good example of this, where we're throughout the life cycle of the product, we're going to be coming back on and redoing testing over and over again to see if new vulnerabilities have been identified. So test automation is a really nice way to do that, which is really different than this. What we're doing there is executing on many different tests automatically and then producing the result to bring back into test management so that we have this traceability and we understand the implication of the test result that we're identifying. So if we want to look at a design report, this is a pretty good example. And one of the things I'd like to do here is talk about the implication of this testing as we go. But essentially we have these different requirements and we have a set of test steps that are going to be executed against that requirement. And you can imagine that as we execute on the test steps, we're going to have a result for each step, and then we're going to have an overall result for the test run as a whole. So essentially each test case is going to go through the steps. We're going to say, okay, this test case passed, and then we're going to have multiple test cases typically, and the overall result of the test protocol will also be recorded. So nice thing about this is, as part of the standard reporting, we're going to have all the requirements stated. So what is our definition of good? And then we're going to have the steps that we went through to do the test, all the data that's associated with the test run, and then the test result as part of the reporting. Really a clean way to provide us with evidence that we did what we said we were going to do. Now, in the introduction, we talked a little bit about revisions of requirements and revisions of the parts that we're testing. And I want to talk a little bit about where this is going as we move forward, because those parts, which are the outputs of the design, those parts are traced into the requirements as well, because we have to understand what is going to be the article that we're testing as a result of this activity. The question then becomes, okay, we have this SKU. What's the revision of the SKU? And what's the revision of all the parts, the component parts that are part of that SKU? So again, we have the requirements and we have the systems modeling components of the design. So the capabilities, the functional chains, and the functions, they're mapped in. Test cases that are traced to the requirements that we're going to be testing. Now we have the parts. So we're going to have the SKU at the high level, then we're going to have parts which are broken into subassemblies. So it's both subassemblies and the part, individual parts. And then we're going to have attributes. The parts are going to be traced into the functional requirements, the system and design requirements. The overall design, the SKU, is going to be traced into the user need, because we're going to be checking the completed design for whether it provides the performance that's been defined in the user needs. And then the attributes or specifications, which are components of the parts, are going to be traced to those physical requirements so that we can show in the design everything that we said we wanted to deliver in the design. Now, one of the problems here is all of these things have revisions. So it's not just we have a part, but what we're talking about is testing Rev B or Rev C of the part. We're not just saying what is the head revision of that part, what part number are we talking about? What we're talking about is what is historically the version of the part that we're using as the device under test for this particular test. So this becomes a very important part of the traceability, because I need to understand what the match is. We have a test result that's going to come out. Yeah, but what system requirement did I test it against? What historical revision of the system requirement? And also which part or subassembly was used in that test? These are two pieces of information that are really important because as that changes over time, we're going to have to redo the testing and come up with a different SKU version that's going to be shipped. So when we identify the SKU, what that's going to give us is a precise BOM. And that precise BOM is going to have the revisions of all the high-level SKU, but also all the component parts that are part of it. So when we approve that precise BOM, we're going to end up with the manufacturer BOM and the bill of process that's going to be shared to the manufacturing operation. So what does our design report then look like? Now we have revisions of the requirements. We have also revisions of the parts. So now the test result that we're concerned with is the test result that's associated with those two things being matched. So we want to know for the revision of the part that we're testing, do we have a test result that's good and what revision of the requirement was used as the input to that test to define what is our good performance. And that can be achieved because we're now in the PLM system selecting the SKU so that we understand what part we're testing it against. So why is this hard? This is something that is sometimes difficult to understand. And I'm talking about this because this is a very typical problem inside of most large companies. It's very common that we have many different applications of a type. So in document management, we have many different things: Documentum, Viva, Team Center, Windchill, Agile, SAP. All these systems are used for document management and part management if we talk about PLM systems, but oftentimes different applications are used that aren't PLM systems for managing your parts. So Team Center, Windchill, Agile, SAP, very commonly Eris. There's a whole bunch of different applications of a type, and typically companies have more than one of each of these. So when I go to start talking about how am I going to manage my test, the revisions of those parts really matter. Well, where are you getting those revisions from? So you can imagine now, okay, let's just talk about, we have document management and we have part management. Where is your mechanical design? And very typically, if you have more than one document management system or more than one part management system, you're going to find that those different artifacts are carried in different applications across the company. So you might be managing your software in a completely different system than you're managing your mechanical, or electrical in a completely different than, formulation. So, and this is really very typical. I've often found that if you want to do some kind of a chemical product, it's not uncommon that people put that into SAP and then they put discrete in another tool, PLM tool like Windchill or Team Center. So one of the things that we have to understand is that when we start doing testing, we're going to have to reference the historical revisions of these parts so that we understand what we're testing. Well, those parts are likely going to be all over the place. So we need to talk about what is the complexity for doing that kind of traceability. So I'm just going to make a few recommendations as part of this. Hopefully this provides you with a little bit of bonus content, but really what you'd like to do is get to the place in the company where you have one application of a type. So we have one ALM system, one PLM system, one manufacturing execution system. The more complicated that gets, the more you have to think about integration between these different applications and how you're going to manage that complexity. Because point-to-point integrations become difficult when we have more than one vendor involved in the different application set. So the second one is complex requirements traceability in one application. So if we're going to have traceability between test cases and the different requirement types and how is that related to functions, the more you can do that kind of complex traceability in one application, I think the better off you're going to be. When you start crossing applications, and I've had people say, I'm going to do my user needs in one application, I'm going to do my system requirements in another application. Well, every time you do that kind of a break between applications, now you're talking about linking across applications, which makes it more difficult. So if you can, get the traceability as much as possible into one design. We want to align data with application strength. And what I mean by that is several times people have asked me to put the bill of materials inside of the ALM tool. Well, the ALM tool isn't designed to manage massive files. And, the PLM system has been specifically designed for that and also has all of bill of materials hierarchy configuration management functionality built into it. So we don't really want to put, despite the fact that we want the traceability in one tool, we don't want to use databases for what they weren't intended to be used for. So keep the parts in the PLM system, keep the requirements in the ALM system, and I think you'll be much happier from a system performance perspective. Next one is develop the system with an understanding of what reporting is desired at the project completion. So we have these data models and developing the use cases for what report are we looking to use to show that the design is complete and what needs to be included in that report. We kind of want to understand those use cases before we jump into data models. It really helps to have a little bit of experience in deploying these systems so that you understand better what the ins and outs or the pros and cons of any particular process are. And finally, consider a robust integration bus. And part of the reason for that is even if you're in a perfect scenario, you're a big company, you've moved to the place where you have only one supplier of all the applications. That might all be true, but I've never seen it happen. But if it is true, it won't be true in the future because at some point in time, you're going to have an acquisition. That acquisition is going to bring in a set of applications that are different suppliers. You're going to need to have a strategy to figure out how to at least resolve the data into your preferred systems, but more likely you're going to have several of them. So just one of the things I'd recommend is you consider a robust integration bus. EQ Technologic is our preferred solution, and we'd be more than happy to talk to you about that when you're in these complex application environments. Okay, manual. That's the big issue there. Typically, in big companies, the linkage between the test result and the outputs or the parts, that's all manual because there's so much complexity in the application set. So we really want to talk about how to do that so that when you do your verification and validation testing, that you have a clear understanding of the relationship between the parts and the test results. Okay, well, that's today for verification and validation. This is my contact information. Thanks again for coming to Lunch with Larry and getting to know us a little bit. Hopefully next week we're going to talk about risk management, and that'll provide you with sort of this negative view of the design. How do we assure that bad things don't happen in the design? That's the topic for next week. So thanks again for spending some time with us. Talk to you next week.